Hello YouTube, I hope you're ready to program some chess. We should look into move generation. The final thing we need is to check for check. So in all of these positions we generate, it's quite possible that your own king will end up in check after the move. So what I wanted to do was do something like the active color. Let's say something like new positions. Can do it here. We could also just do it here. No, so I want to take each position and I want to say I only want the ones where king is in check, where the king is not in check for the current active color. And I forgot game.position.active color. So can we do something like this? Let's see if it works. So we need a position thing, position, and we need a color, and it's a Boolean. So the problem may be something with moves or whatever, but let's get the thing over here. Oops. Expected struct found reference to a reference. Very interesting. I mean, I don't mind particularly, but it's weird. Okay. Perhaps a simpler way to do it is just for position and positions. If king is in check, then take a reference to the position. That's probably good enough. And the active color. And if that's the case, then we just skip this one. Otherwise, we push the position. How about that? How about this? Okay. So now we just need to find a way to check if the king is in check. So the way I thought to do it was look at the king, check all ray attacks, and see if we intersect with an enemy piece, and also check the knight moves. Knight moves. Okay, so let's say enemy color, and I think it would be nice to have a function like this. So let's go in here and look at the color enum, and we will just make that function. which will match on self, and if it is white it will return black. Black will return white. Because then we can say ray attacks, which we also need to get fed in. So actually going to just give a reference to the game. And we'll say the color is the game position, active color, and the ray attacks. How is it we get those? Just ray attacks, good. Not like that. And does that work? Okay, so now we basically need to find the king. It's kind of interesting. So we need to do something like for piece in position.pieces. Okay, I found a nice way to do it. So for each of the pieces we iterate through them and we try to find the piece where it's a king and the color is the color, and we just kind of unwrap it because there should be a king. So now we have the king. Now we want to apply all of the ray attacks, and so basically in the same style that we did here, and or rather here, and see if we hit an enemy piece. So I think I want to make a new macro for that. So let's call it something like check check if attacked, and it will be structured similar to this one. So I will copy paste it for now. And we will say, yes, we need rays, we need also this one. We don't need positions. We do want the king, and we may need the game. So yes, we can do this thing to get our own occupancy and the enemy occupancy, or whatever, and then we get the blocked rays here, and then basically I want to see if these ray attacks intersect with an enemy piece. So the return value of this block maybe we'll make it into a block. The value of this block should, maybe I don't need that. Not completely sure how this works, but whatever. So, does this intersect with the enemy occupancy? And now let's say I want to do that for each. So we'll say is attacked equals, check if attacked, check if attacked, and we want to say game, we want to say ray attacks dot north rays. North is forward, then we give the king the game, so should either be that then we can do this one and so on. And here we are. So I just made a helper macro to make it easy to write this, which just takes the rays we're interested in, whether it's a forward ray or not, and then just expands to this macro that uses some local variables. And then this is the whether or not the king is under attack, and then we simply return that actually. So we remove that format. Let's check that I didn't make any typing mistakes. Right, so made one mistake, at least one. No rules expected this token. What do I have to? Okay, we make it an expression. Right, should be king. Just to make it completely clear. And here it should be the king's position. Okay, so we actually do need a block, it looks like. Great. So that should be, okay, so we still need the knight attacks. So how did we generate? We also have a struct for those. So let's say attacks, or rather knight attacks, is the game. We look at the knight attack structure and the position for the king. And so we need this one again, which is a bit annoying, but and it should be the enemy. And then we simply need to see if there is a knight. Okay, so actually something I just realized, that it's not enough to check that there is a piece there. We also need to check that that piece actually can do a ray attack. that makes it a little bit annoying because okay, so let's just call this one overlap, and if overlap is 0, then we're good. We know it's not attacked. So how do I write that? Write like that. Otherwise, we want to see this. I think I have a extract bits, and yes. So let's say the locations of the overlaps are at this. And for each location, I want to check if there's a piece of the correct type. So for location, so let's say mute is attacked. Put it to false. And now this is an index. So we want to say index for a square, so we can say the square is game position squares index. And first of all, something has gone wrong if it's empty. It's very highly nested. It's a little bit annoying, but whatever. Leave it for now. Something has gone wrong. Perfect error message. Otherwise, I mean, it should be occupied and should have a piece index, and the piece index then points to an attacker. So game positions pieces piece index. And let me just assert that it's alive. It should never not be alive, but and then we want to check. We want to say that attacked is equal to attacker the piece type, and so we want to check against some specific piece types for the specific array. So we want to say like types, and it will just be this, an expression, whatever. So we want to say for attack type in types, and there we go. And that's fine. And then we say the kind of we can say here if is attacked. You know what? We can call this one outer, and then if we're attacked, then we break from outer. And then the value is attacked. Okay, now just the problem is we need the types. So we put them in here. Okay, so for north race, I want to check for the queen. And the queen and the rook. And here I want to check northeast. I just want to check for the queen and the bishop. And here the queen and the rook. And the queen and the bishop. There's some kind of pattern here. Okay, so now that should be fixed, and then we have another to do. Check for whether the enemy king is attacking our king. So, but we'll get to that. Okay. So now we have the knight attacks that can hit the king. We have the enemy occupancy. So let's say if there is an overlap, let's just make a variable actually. So knight attacks overlapped with the enemy occupancy. If the overlap is not 0, then we want to do some checks. And again, we need the positions, which is the bits of the overlap. And then for positions, we want to let the square be game position dot squares and the position, and again if it's empty, empty square but expected overlap, expected occupied, and then we can get the piece index, and the attacker is so actually let's make some kind of short circuiting. So if we're array attacked already, we don't need to calculate anything else, so we just return true. And the same here, so if the attacker is the game pieces, game position pieces at the piece index, and if the attacker's type is a knight, then we can just return true. And okay, there we go. And finally, we check for the king. Let's make some helpful comments. Kind of delineate what we're doing. So check arrays. Okay. So how did we do that for the king? I'm sure we had some. Ugh. This is not very nice. I will copy it, however. Actually, we have this index function will give us an option. So we should be able to do something a little bit nicer. first of all we can get rid of this, and then we can say if let some index equal to index of the row, which we need to define as the row column of the bit scan of the king's position, like so. And then we can do this. Then, okay, it's a little bit unfortunate with the zoom level. Okay, then this is a valid index, and it's just an index of a square, so we can say that let's check that square, and if it's empty then we don't need to do anything. If it's occupied by a piece, then let's get the piece, and if the piece color equals the king's color, well, let's say if it doesn't equal, then we need to do something. And we also need to check for pawns. This is but then we are finally done. Okay, so let's do this. Okay, so if the piece is not the king color, then we can say if, now I actually want this to be a variable. So if we're either on the same row or the same column as the king, then the only piece that can attack us out of kings or pawns is the king. So then we just need to check if this enemy piece is a king, and if it is, then yes, we're under attack. Now, but if we're not on the same row or the same column, then we need to check if it is actually, so we can do this. And then we can check if we also need a direction thing, so we'll say let direction match king color, and it will be 1 or -1. So this is the direction in which we need to check for enemy pawns. And we will say here, okay, it's either a different, no, that's not good enough. It has to be both. So the column is not the same, and we can even do better. We can say that new column has to be absolute value of that has to be 1, and the row has to be direction. Yeah. So if that is true, then if the piece type is a pawn, then we return true. Otherwise nothing. And this is just junk. And if we make it all the way here, we can return false. Now let's see the many ways it went wrong. Labeled expression must be followed by colon. Fine by me. Occupied. So this should be square. And types is not found because it's like this type thing. And we'll have the same thing down here. And evidently there's a different one down here. Oh. Okay, it doesn't like to have this many named things, so I will just not name it. And we will just have a bunch of breaks. So we break out of this one, and then we'll say if attacked, we break again. And there's now something in 87. Ah, oops. So if there's no overlap, actually don't need this variable, right? So we can just, so if there's no overlap, we just return false. It's not on attack, otherwise we have to check. And 86, there shouldn't be a semicolon. And 89, we do need the variable. Damn it. So if there's no overlap, and this is not the overlap, this is the overlap. Okay, now it all makes sense. And 97, there's something. And it shouldn't be positions, it should be position. Now there's something down here. Okay. Don't need this to do anymore. And 174. Not sure why it's complaining, but I'll allow it. Okay, so we have the king is in check, and we have, that's the new function, which we want to check works, and then we should also check generate moves where, or test where there's actually a move where the king comes into check. So I will just write some quick tests. So I just thought of something while I was writing the test, which is that the position here that we're feeding in has the new locations of all the pieces, and the game has the old. So we need to make sure that we don't use the positions from the old, from the game struct. Now here we use the color from the game struct. That is correct, because this will be the color that we're currently generating moves from. And so here, okay, so here might be a problem because we're taking in the game and we're using yeah, so we need to get rid of that, this should be okay. And I think we don't even need the game, we just need the position. So let's go down here where we're calling it, and not the game please, but the position. And that should be good for there, for all of these ray attacks. So let's check down here. Again, don't use the game. Don't use the game. Don't use the game. Now, oh my god, look at this beautiful nesting. So ideally we should probably not even give the game in, but just the things we need. So let me just refactor that. Okay, here we go. Now instead of the game, we just take the color, which is the active color. We take the ray attacks, we take the night attacks. Now there should be no way we can use the wrong thing. There was also a bug up here, or a problem, where it referred to the game instead of the position. So let me write this test. Okay, so the test passed. Now let's do one where it's not in check. So for example, we can change the queen into a white queen. Then we just assert that it's not in check. Also okay. Then we can do one where it's in check, but it's a knight. So let's add a black knight at, let's say, f3. It's also okay. And now let's try where it's not in check, and the reason it's not in check is because it's blocked. So we will add a bishop at, let's say, f2, g3, h4, and we will also add a white pawn at f2. Now it should not be in check. And that was also okay. So it seemed like it worked, but now let's also make a test where test move generator doesn't generate in check, something like that. We don't generate positions where the king is in check. And now an easy way to do that, or the easiest way to do that is, I think, let's add a king at e1. Let's add a pawn at e2. And finally, let's add an enemy queen at d7 or whatever. Now, so the king should not go to d1 or d2, but it should, so if we say like, keep forgetting my own APIs, but let's say generate king moves and generate king moves. So we'll take the king, which is the 0th piece, and I think as a reference, and we'll also take the game. Then the number of positions should be 2, because we can go to f1 and f2, and we have this fancy technology up here to say f1, f2, like this, and then we can say for position and positions we will assert that expected positions contains bit scan of the piece of the king's position. Okay, try that. That failed. That's very interesting. So it does generate some moves that it shouldn't. Okay, so I just wanted to print out the actual positions that it's generating for the king, and it is indeed generating D1 and D2. So there is a problem here, and let's just check if it even hits this one. Hello. And now I just want to just run doesn't generate. Check with no what's the thing you call it? Right, so I want to run the test with generate and check and no capture. So it just runs this. It never thinks it's in check. So let's try this. It also didn't. What exactly is going on? That's because we never call into this, of course. Oh my god. Okay. Maybe we, just to make testing like easier, no. We need it here, otherwise it will be repeated many times. So let's do something. Let's artificially set it up so that there really is only this. Okay, now it worked. So it was simply because we forgot to add this filtering because we call generate king moves instead of the generate moves. So I just add an extra pawn such that the white pawn cannot move, and that means it will only try to generate moves for the king. And then it worked. Then it did not work. Then it did not work. Let's run this again. E1. What? So it looks like pawns don't really block each other. And then also, let's add a black pawn on d5. So now there really should be no moves. So like that. And yes, it failed. So there is a bug in generate pawn moves. My god, what a function. And part of the reason is we're just sort of naively pushing things. So we've pushed all of these so I don't know. Index is index, row plus 2, column, and position is 1 bit shifted, and then we need to say if there's no, and actually we need to check another thing as well. Which is that position and enemy occupancy is 0 and position 2 and enemy occupancy is 0. Then we can push. We need the same thing here. Except there will be minus, minus, and that's, and these are taking a piece, so that's okay. Here we just, and that's some en passant, that should be fine. And this one also doesn't work, so we need the same thing again. Like that. Let's run it. That did not work. So these we can unwrap. And take this one, unwrap that, and put the expect up here. And try to run it now. That worked, kind of. But it didn't solve the problem. So. Okay, so it actually solved the problem for the pawns, but did not solve it down here, where now we only have F1. And maybe my visualize, no, it's there's no way it can be. Because now there's a pawn, so actually it's correct. So instead of a pawn, let's add a rook. Then it should be fine, yes. Okay, because before the pawn was blocking F2. All right, so I think that was pretty good, because now we have a fully fledged move generator. It will only generate legal moves, and it will generate moves for every piece type. Now we have all these unit tests, which are very good, look at all these beautiful unit tests. But it is not, it's not quite enough. And the way you normally test a move generator is to try to generate moves out to 20, like try to count the number of possible positions out to 20 moves. For example, out to 20 moves, and then compare it with some standard implementations or some standard calculations. So we'll start to look at that next time. And we also need, in that case, to filter out positions, because filter only get the unique positions, because, for example, d4, d5, e4, you can get the position that way, but you can also get it with e4, d5, d4. So different move orders will lead to the same positions, and we don't want to include them twice. So we will also need a way to compare positions. But we'll look at all that next time.